Welcome back, everybody. This is going to be part 2 of the area of a polygon, lesson number 30, homework review. Here we have a question where a triangle plotted on the coordinate plane has vertices of 2, 3, the square of 15, 3, 4, 8, which the following is close to its area. So the first thing would probably be a good idea to plot these points. So 2, 3 goes, so we go 1, 2, we go up 3, 1, 2, 3. This will be point A. Okay, and then our second point is square root of 15. Now, square root of 15 is a little less than square root of 14, so that's going to be a little less than 4. So we'll put this here at a height of 3. And finally, the measure, so the third point is going to be 4, 8. So here we go. Here's 4, up 1, 2, 3, 4, 5, 6, 7, 8. So it's not a right triangle, and mainly because of the fact that the coordinates do not line up vertically. Oops, not this one. Instead, I want this measurement here, this one. So it looks like a line segment, solid line segment. Okay, so it kind of looks like a very close to a right triangle, but it's not a right triangle. Okay, so now what we're going to do is use our formula of 1/2 base times height. And I know you're probably saying to yourself, well, how are we going to find that? Well, first things first. Okay, so the base of our triangle is going to be this horizontal distance. And so we're going to use the distance formula. And let me just label the coordinates here. Okay, so this is, I'll call this point A. And I'll call this point B. I'll call this point C. So, all right. And so we'll use AB as our base. And so the distance horizontally is going to be, so the distance, so AB is equal to the square root of our distance formula, which will be the square root of 15 minus 2 squared plus, and the difference of the y value is 3 minus 3, which is 0. So now AB is just going to be the square root of the square root of 15 minus 2 squared, because this is 0. Okay, so now if it's the square root of anything squared, you're just going to get that difference here of the square root of 15 minus 2. Now let's bring our calculator. So we do the square root of 15, square root of 15 minus 2. And we're going to get this value of about 1.87289, and we'll hold that in the calculator for now. Now, what we want to do is we want to find the height. Now, the height here is just the perpendicular distance, and so our height is actually going to be outside of the triangle because it's just slightly outside. So here, notice how the height is going to be slightly outside of the triangle. It is not BC because BC is a little slanted, but that height compared to our base here, and I'm going to extend this here from AB to array from array AB. So we're looking for that perpendicular distance, that height in this case. So here, that value we can actually find. That value is going to be, in this case, 8 minus 3. So 8 minus 3 is equal to 5. So I know you say, so well, how do you know that? Well, the height of a triangle is just the perpendicular distance to the base, and sometimes our altitude will be outside of our triangle. So our area is still going to be 1/2 base times height, and so we're going to take our area of 1/2, and we found for the square root of 15 minus 2, which we found on a calculator. We're going to multiply it by 5 and then divide by 2. And so now let's go back to our calculator. So we're going to take this value, 1.872983346, multiply by 5, that's multiply by the height, which is 9.364916731, and then divide by 2. That's the 1/2 part. And we're left with 4.682. So we have, in this case, our area is approximately 4.682, which will be choice 1. Okay, so it is a good idea to draw this null, and we can estimate. We'll use a calculator to help us find our numerical values. Just again, find our base and our height for our polygons here. All right, so that's question number 4. Let's continue with part 2, question number 5. Here, parallelogram ABCD is shown below, with AD being 10 centimeters, and AECF is a square with a side length of 8 centimeters, which means in this case is AF is 8 centimeters, so is FC. Now, if we can find the measure of FD, we should be good to be able to find the area parallelogram, because the area parallelogram is equal to just base times height. We know the height to be 8. So we know this to be 8 centimeters, but we need to find the base here. And the base would be CD. Well, we do also know, however, that in this figure, AFD is a right triangle. Well, because angle AFC is a right angle, angle AFD is a right triangle. And when we want to try to find the third side right triangle, we use Pythagorean Theorem. So I'm going to call this side A, and this will be B, and this will be C. So we use our formula of A squared plus B squared equals C squared. Now, the B here for Pythagorean Theorem is not the same as the base. So we're going to find A squared plus 8 squared is equal to 10 squared. So A squared is equal to 60, so plus 64 is equal to 100. Subtracting 64 from both sides, we're going to get A squared value of 36, and therefore taking the square root of both sides, our A is equal to 6 centimeters. Now, again, when we take the square root, is a positive or negative value, but we cannot have a negative measurement. All right, but our base we're trying to find. If FD is 6 and FC is 8, that must mean CD, the base, is 14 centimeters. So now we go back to our formula here. So our base in this situation is equal to 14 centimeters. And so now, since area equals base times height, our area is equal to 14 times 8. So 14 times 8, that's 2, carry the 3, 8 plus 3 is 11. So our area is going to equal to 112 centimeters squared. Please make sure you use the proper units, okay? All right, so ladies and gentlemen, this is going to be how we find our areas. Again, a lot of times, it's not just so much as plugging numbers to a formula, it is also finding the measurements we need, making sure that we're not just randomly plugging numbers in, but we're trying to find the base and the height for this problem, and also the base and height for the previous problem as well. So this will be the end of part 2. If you found this helpful, ladies and gentlemen, please leave a like for the video. Please leave comments or questions below. And, the key thing is this. I know a lot of you, some of this is, if any of these videos are difficult, just watch them over again. Leave questions like, why is this the case? Now, why are we doing this and all? But for example, why did we find FD? Well, we want to find the base of the entire parallelogram, not just in this case, not just the case of the area of the square. I mean, we could have found the area of the triangle and added them together times 2, and and add 2 of the triangles, because a triangle BEC is the same area as triangle AFD. Add the square, but base times height is usually the formula we're going to use for a parallelogram. All right. Again, make sure you show work on your homework, ladies and gentlemen. All right, because the work is more important than the answer itself. Remember, the key thing is how we get the answer. Thank you so much for watching, and as always, we ask that you just make sure you're just learn the material. That's more important than anything else. Okay, take care, be safe, and I'll see you in the next video.